Hello friends, welcome to this video on areas of parallelograms and triangles. In the previous session, we learnt about parallelograms lying on the same base and between the same parallel lines. In this session, we will learn about the areas of triangles and parallelograms that lie on the same base and between the same parallel lines. So let's start. Friends, look at the figure given on the screen and tell what would be the area of the triangle AQR. It is given that the quadrilateral PQRS is a parallelogram and its area is 120 square centimeter. Here, triangle AQR and parallelogram PQRS lie on the same base QR. Can you tell anything more about the figure? Are these shapes located between the same parallel lines? Let's check. If we join point A and point P in this way, then we can see that these two shapes are located between the same parallel lines AS and QR. Now, what can you tell about the area of triangle AQR? Let me give you a hint. Let's draw a line parallel to side AQ from point R to side PS, which intersects side PS at point T. Here, we can see that in quadrilateral AQRT, a pair of opposite sides are equal and parallel. Therefore, it is a parallelogram. Now, let's talk about the area of parallelogram AQRT. We know that because quadrilateral AQRT and quadrilateral PQRS are both parallelograms that lie on the same base QR and between the same parallel lines AS and QR, therefore, their areas will also be equal. That is, the area of quadrilateral AQRT will also be 120 square centimeter. And if we consider the parallelogram AQRT, then AR is one of its diagonals, and we know that the diagonal of a parallelogram divides it into two congruent triangles. And the areas of congruent triangles are equal. Therefore, the areas of triangle AQR and triangle RAT will also be equal. Since parallelogram AQRT is made up of triangle AQR and triangle RAT combined together, we can write it like this also. Here, we can also write triangle AQR instead of triangle RAT. That is, the area of triangle AQR will be half the area of quadrilateral AQRT. Therefore, the area of triangle AQR will be 60 square centimeter. Can we say that if a triangle and a parallelogram lie on the same base and between the same parallel lines, then the area of the triangle is half the area of the parallelogram? If we look carefully at equation 2 of this example, then what can we tell? We know that the formula for the area of a parallelogram is base into height. So, with the help of this formula, we can also find the formula for the area of triangle, which will be half into base into height. And since the triangle and parallelogram lie on the same base and between the same parallel lines, their height is also equal. Therefore, by this formula also, We can say that if a triangle and a parallelogram lie on the same base and between the same parallel lines, then the area of the triangle will be half the area of the parallelogram. Friends, that's all in this session. Today we learned about the areas of triangles and parallelograms located on the same base and between the same parallel lines. We will meet in the next session with some related questions. Thank you.